Okay. Okay, this time it works. I think. Kind of check though. Okay, so counting bits. It's something like I kind of looked at this problem yesterday. I didn't manage to finish it. So let's start the timer. Man, it's so laggy, dude. Like I can't. I can barely like. Okay, um, well, I've kind of looked at the solution, so it's kind of cheating. Um, in some sense, I've not looked at the full solution, but I just kind of looked at the general direction and some of the important pieces that I might need for this problem, which I completely wasn't aware of before. Especially the bitwise operator. I wasn't completely aware of this. Also, I don't know the chat. Uh, Let me open the chat really quick. Uh, while that happens, oh god, not this again. Jesus. Yo, guys, I'm trying to like get this thing going, but it is not helping. Coolio. Okay, this maps to 4. This maps to 3. To 2. This maps to 1. So the solution I was looking at yesterday seems to be like this. Like 3 was like, okay, so first mistake I kind of did yesterday was thinking if it is even, for even numbers, right? Well, okay, clearly 5 minutes is too long, too short. Hey Chucky, what's up? Welcome to the stream. Solving leetcode 338. You can hop in. So if it is even number, so one thing I made a mistake was if it is even number, then well, now I know that it's not like the number of ends with 0. Ends with 0. Right? So the solution I was looking at is like, imagine you have your number n, right? Which is your, say, imagine your number is x. Right? And then, well, obviously your bit, imagine your number is x, right? And obviously you would have like your 0 1 0, like whatever, like starts, imagine this, and then 0 1, and then dot 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 dot, goes on forever, and then has a ending number, right? Which is 1. It's either 1 or 0, right? um like, we really don't care. Okay, for what can we tell by this about x? Well, what we can say is like, if it ends at 1, if it ends in 1, then it is an odd number. Okay. And if it ends in 0, um if it ends in 0, um should not do that, do I? Right? Let's take that, copy that, paste that. Okay. And obviously, if it ends in 0, then it's even. Let's I actually don't mind, dude. I can do both, but I prefer tablet because it's much faster, dude. Like you can copy and paste stuff. Like you know what I'm saying. When you make a mistake, you don't have to erase the whole thing. You can just kind of Control Z and like kind of like steps back. Yeah, so it's more efficient that way. You make use of technology. You know, like you're much better with technology. It's like you saying, I don't want to use internet. I'd rather use like go to the library. I mean, you might want to go to the library in some cases, but most cases you don't want to. You know, like, so I do kind of prefer tablet. I don't want, no, I don't, but I can't afford iPad, so I don't have an iPad. Anyway, so yeah, it's even and odd. Like, if it ends in 1, then it's odd. And if it ends in like, say 0, then it's even. Okay? So if X was something and then you have like dot 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 dot, right? So that's that's the first thing we can kind of infer from this particular. Okay, so like now that we have that, now let's think about like number like 3 itself, right? Like 3, what is a binary representation? Well, 2, that's 1, that's 3, right? So what we can do is like, well, we can kind of like imagine just like having a detector over here. Okay. Having a detector over here that detects like, I don't know, at the very last bit, like there we can have a detector, like almost like a detector. Um, okay, so this detector will tell us if it is 1. This bit is 1 or 0. Okay, if is it 1 or is it 0? This and that's how we kind of find how many bits there are. Um, yeah, I think that's. Yeah, I think that's how we can find how many bits there are. Like almost like this detector analogy. Um, and for this detector to work, right? What we need to do is like we need to chop off like a part. We need to chop off this part, particular segment of the detector, right? So like if it is 3, well the detector says yes, the last bit is. Imagine there's a counter as well here. Uh, Actually, I'm just going to uh, counter, okay, and then the counter is incremented by 1, and now we chop off the last bit, okay. So now the detector is kind of looking at this particular one, okay. So this has been chopped off. Imagine it just fell off the cliff or something, okay. Now the detector is kind of looking at, okay, so it says yes, there is 1, and then the counter is incremented by 1. Okay. Okay, so how to first, now there's 2 things we can do over here. First build the detector and build that like falling off the cliff analogy that we go on. So how do we fall off the cliff? Well, okay, it turns out, imagine this is the cliff, right? And then here's your water with sharks, okay? And here's your bit representation, like yeah. Okay, cool. Well, we want to shift the bit. We want to shift the bit uh this direction. And in Python we do that by I don't even know how do we do that actually. Is this shift left or right? Need to check. Bin of 3 1. Bin 3. Yep. Uh. Yeah, so in Python, we can have this as like, imagine if this was, this number represented x, right? This particular number represented x. We would be pushing this number, binary representation, the bits, in this direction. So, well, it would be like by 1. So we're saying, okay, one of the digit kind of falls off the cliff, right? And then we can imagine like there's a detector over here kind of detecting like the last bit that is over here. So it's almost like a queue, like a free queue, like, which is really nice actually. Actually, wow, that's a really sick trick. Now that I kind of think about it. So I guess like, can we implement this? So for any number, like, so yeah, for any number we kind of like basically check, like with this detector-ish example, like, so imagine like you keep like, fall, like make like pushing the last bit off the cliff by bit shifting, right? And then eventually you will reach a point where it's 0. Yeah, exactly, that's a good point. Yeah, when do you stop though? Like, that's a good point. When do you stop? I mean, theoretically, right? You could have a number with a lot of zeros, right? Like, you can have like just zeros all everywhere, just zeros everywhere, and then like there's like 1 over here. Uh, right. How do we say like, when do we? How do we know we reach the end though? Maybe we can kind of know how long this would be. Like, that's one solution, right? Um, I mean, yeah, I mean, like, yeah, we have to know the length of this thing. We would have to know the length of this thing. Well, what is the length of this thing? Not quite sure, actually. Mm, not quite sure. Find the length. Yeah, exactly, dude. Like, how would we find the length? Um, okay, maybe we can kind of like check for patterns over here. One. Okay, 1 0 1 1 1 0 1. Okay. Um. So 4 is 1 0 0 1. Uh. 2 3 4 5 is, well, 0 1 1 1. Okay, 6. Okay, how can we tell this is? This is 3. The length is 3 over here. The length is perhaps 2 over here. The length is 2 over here, and then maybe like, obviously the length would be 4 over here, right? Um, and so on, so on. 4 over here, so that would be 8, right? That would be 8 over here. This would be 4. So maybe it's like a division or something. So like, let's see, 8 divided by, let's see over here, 8 divided by 2 is what, like 4? What about 9? So I know definitely 9 falls over here, somewhere over here, right? So like 9 divided by 9 divided by 2 is what, like 4 point something. Is that what it is? Like just integer division. Okay, well, let's try 4. Well, I know 10 falls over here. Well, I know like there's 4, 0, 1, 2, 3, 5, 6, 7. So 10, 11. So I'm sure like 12 will be like 5, right? Like 12 would be starting 5. So let's see if that's correct. 12 divided by 2 is like what? Oh yeah, 5. Okay, so it's like integer division. Okay, so looks like the length would be like actually just x, like integer division by 2. Oh, sorry. Yeah, my bad. Oh yeah. Okay, that's a good point. Oh my god. Yeah. Holy crap, dude. That's a good catch. 12 divided by 2 is 6, not 5. Oh my god, dude. Uh, I actually knew this. I probably made, silly mistake, dude. Happened, shit. Yeah, it's 6. So let's have a look. Is it actually 6 though? Like, that is not. We can't do that. Well, it has to be 5 though, right? Like, it can't be 6. Well, what is binary representation of 12? Well, let's have a look. Okay, 12 is what binary? What's the representation of 12? Well, let's have a look. Because my first guess was this. But this is definitely not true. Because this is not a power of 2, right? So yeah, that is correct. So you got me there. Am I? Wait, but I thought there was like 4 numbers. Like it jumps by 4. 1, 2, 3, 4. 1, 8, 9, 10, 11. Am I missing something here? Because every 4 number, like you seem to kind of get a digit up. So okay, forget it. Let's just check out the Oh wait, what the hell? It's every 3 0. Okay, so well, this is 8. Okay, so it's kind of like this, right? Are you sure? Am I tripping balls right here? Okay, let's check. Yeah, that's what I thought. So when does like it? Okay, maybe I am wrong. Okay, I have to accept the fact that I am wrong over here. Maybe the pattern is not so clear over here. Maybe the pattern is not like every 4 number it goes up. Every digit, like it goes up every digit. Maybe it's not that. which kind of makes sense because the number of bits you can store within here is much bigger than just here, right? Because of the permutation and combination, we can have more combination. Okay, so well, our problem is to kind of find the length of this particular thing. How would we do that? Chucky, any clue? Literally, dude, like how would we do that? Hmm. It's an interesting. I mean, once we solve this, like we kind of solve the problem. Like we can kind of write code for it. Okay, so how, like ow. Well, okay, let's, maybe it's not the length. Like it is quite hard to find the length. Is there other way around? Let's see if what happens. Oh, I get it. I get it. So it's like, imagine you have a like detector over here, right? And you keep dro- falling off these bits, right? Um, right? Um, you know, right? What you can do is like you can kind of like check the value of this, right? If it is zero or not. You don't actually have to. You don't actually. It's based off power of two. That's right. Yeah. So what I'm trying to say is like, well, I guess like, um, yeah. So as you kind of put like this particular, you push this off the cliff. Like you can, but you still have the ability to kind of check the value of this, right? Like what does it represent? What number does it represent, right? Um, and if it is like, and if it is like zero, if it is like zero, then we know that we have nothing in front. We have nothing in front to kind of push off the cliff. We have reached the end. Right? If it is not zero, then obviously we have to keep pushing it off. So that's it. I think that's the algorithm over here. Basically, okay. So we're gonna push off the cliff by doing this one by one, right? That's the bit shift operator. That's the pushing off the cliff. And well, we have to also implement the detector. Well, how do we do the detector? Oh, the detector is going to be like, remember the odd and even? Yeah, I think we can kind of get to this, but like, um, if this, if this da 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 whatever number you have right in binary, um, is some represented by some number y, right? Um, if that modulo 2 is not equals to 0, then what we have is odd, right? Uh, and therefore we need to increment the counter by 1, right? We need to increment the counter by 1. Um, okay. And then if it is even, well, we don't do nothing. Do nothing. Well, we can kind of say increment the counter by 0. It's the same as doing nothing, right? And then we push off the cliff. Like we push it off the cliff. Um, yeah, we push off the cliff. Okay, we found the algorithm. Cool. Now let's just implement this really quick. By the way, Chucky, tell me if you're not seeing the like code as I'm coding. Um, yes, I need to focus. This is a hard part of the stream, right? Like, also plus like I'm trying to verbalize this. I'm also trying to verbalize this because, and I'm trying to verbalize. I know it might sound, might sound come off like I might come off like I'm not focusing, I'm not thinking, but I'm actually talking a lot because this is intentional. So that in like interview or whatever, right? I have to talk my shit out, right? And So I'm intentionally like putting out words from my mouth. I really don't want to, but I have to. So I'm kind of, this is like a practice round as I go through. So and I have to be, yeah. Anyway, um, thanks, man. Okay, in range. Whoa, Copilot is on, dude. Copilot is on. Like, Copilot is way smarter than me, bro. Like, um, okay. While num is I, well, num is greater than 0. Well, num is greater than 0. What we want to do is like we want to chop off the bit, like push it off the cliff, right? And we want to do that. But before doing that, we have to kind of check if it is odd or even, right? That's what we said in the algorithm, right? And the way we do that is like num. Okay, if it is even, then we know we don't have to add anything, right? Okay, count. Okay, so let's keep a tally over here. Okay, bit count. Okay. Okay, bit count. This is for else bit count plus equals to 1 plus equals to 1. Okay, and then what else? And then num equals to like the chopped off bit of the thing, right? And then once we chop off enough numbers, then it will eventually hit 0. Yeah, it will eventually hit 0, and then we are good to go, I think. And also we kind of, what we need to do over here is that okay, well. Okay, let's initialize the result array. Okay, let's initialize it with say like n number of zeros, so it will be a list containing like 000 multiple like n zeros. So the length of the list result list would be n. Okay, and then what else? And then we just kind of need to basically, right? We kind of need to okay, once we're done with like chopping off the thing and we've calculated the bit count, all we need to do is kind of go to that particular index and set the bit count. And then return the result. Results. Res. So according to my head, This should be correct, but I'm not too confident. But okay, well, we will see. Solution, count bits. Okay, 5. Let's try 5. Assert this to be. Okay, say 0, 1, 1, 2, 1, 2, 2. Okay, I like that. Okay. Python 303. Oh, problems. Python 303. Oh no! Holy shite! It didn't work. My bad. Yeah. Sorry, indexing. Oh no, shit! Ah! Didn't work. Alright, what does it say? Well, it just says I got a wrong answer. Maybe I copied this thing wrongly. You know, sometimes shit happens. So, okay, nah, my algorithm is kind of wrong. So what is going on here, though? Oh. Actually, what am I printing out? Like, okay. What am I printing out here? Oh, dude, I'm so close. I'm so close. Oh, I'm so close. It's actually 0 as well. Yeah, infinite loop. Maybe. Yeah, I'm so close. Well, I would be 0. What happens when I is 0? Well, this happens and then technically. Okay, technically, right? Huh. Yeah, so I'm going through this in my head, and obviously you start with I equals to 0. I equals to 0, and then what? Num is 0 over here. Well, this doesn't happen. So actually, it doesn't work for 0. So what we can do is like, okay, this is kind of a dirty trick. So we add like just one more list because we're counting from, we're including 0. Where did you define n in your code? Well, n is the argument over here. N is the argument over here. Yeah, that's the argument. So we're passing in n. Okay, well, okay, let's not confuse make this confusing. Uh, all we need is kind of just this really, and then the problem is solved. Yeah, I think that's it. Yeah, where did you define n in your code? N is an argument. N is an argument. Uh, so if you are confused with the question, like, think here's the link. You can definitely have a look. All right. Okay. So, let's test. Let's test two. Um. Okay. Let's test two. 0, 1. Honestly, dude, like, yeah. Okay, I'm gonna submit the solution. Huh. So, looks like it doesn't work when n equals to 0. Expect executed output. So, it looks like it doesn't work. Okay, this is obviously such a hacky way. Um, sure, I mean these are kind of like a base case, right? Like, um, I mean this is kind of a base case, so this is okay, right? N is 0 equals to is a base case, right? So we should be fine. Okay. Uh, please run, please. I beg you. Oh my god. Thank you. Thank you. Thank you. To be honest, this is not an optimal solution. Uh, this is definitely not an optimal solution. There's a yeah, I am losing. What makes you say that though? Like, is it me talking a lot? Like, does that make you say that I'm not focusing? Is that what you're saying? Is that why you're saying that? Yeah, I'm actually nervous cuz like I'm nervous to code. Like, I'm nervous to get it wrong, like, Um plus it's streamed. So it's like but then I think with time, like, honestly, I might just chew this, I got plenty of pens. No, I'm joking. I've been biting my nails a lot, so that's not quite helpful. I just yeah, I'm actually afraid that I might just come off dumb in the stream. I don't know why. I really don't care, but I just I don't know why. Uh uh okay, cool. Honestly, bro, I don't want to do that. Bro, this is like not a normal pen. This is like an expensive piece of pen. Um uh I mean, Honestly, like it's like literally like I chewed this up so bad, like it's yeah, my slivers are going in. You know, it's disgusting. So I'd rather not do that. Keep chewing. Like, damn, you seem to be super religious about this chewing uh thing. I mean, sure, I'll hold a pen. All right. I'll try this offline. I'll let you know. I'll definitely give it a try offline. Um, maybe not on the stream though. You know. Uh, okay. So shall we move on to the next question? All right. This time I'll kind of like try to focus more. Um, yeah. Okay. I'll hold it for you. All right. All right. Let's log this question. Okay. I think this one is actually quite hard. I literally couldn't do it. Um, on my own. So I'll literally say 10 out of 10. Um, I might have to come and redo this at some point. Okay, yeah, we good now. Dynamic programming. Oh god. Linked list cycle. Whew. Alright. Bro, this just looks okay, linked list cycle. This is the new problem we're focusing on. Um okay, how do we Okay, there is a cycle in the linked list where tail connects to the 0th node. All right, let's try to visualize this problem. I mean, I guess most visualization is already done for us, but like, uh, probably Google, dude, because Google got like, yeah, Google is like probably like, yeah, they got like really smart people in there, bro. Um, their machine learning, like their deep artificial intelligence, like department is just like the research department is just incredible. Like they just pump out really good stuff. I mean, so does Meta and like all the other stuff, but like, I mean, yeah, just like I don't know, Google's. Um, yeah, I guess I am to a certain extent. There's a uh, thanks, dude. Thanks, man. But yeah, okay. All right, let's do this. Hopefully you got the question that I'm trying to do. If not, I did kind of send you the link. Um, okay, given head. I'm assuming. Well, okay. Well, isn't this like a very trivial problem? Like, so you start here, right? This is your head. Um, and yada yada yada. You can have as many as this, right? The thing is, like, how do you visualize linked list in another way? Like, I feel like I feel like I can take that away from this question. Like, sure, you got the generic, generic like representation of linked list, right? Is there a better way to represent linked list for me personally? Like, so I can solve these problems. But okay, let's just try to solve this with the generic uh, model, and then we can kind of perhaps like tweak it and to our liking. So you got your head, and then you got like, and if it is a cycle, well, it has to kind of go somewhere, right? Uh, so that means like we need to kind of know which numbers came first. I think my question would be like, is are the numbers like unique? So can we have like the scenario like head, and then one, like two, right, and then like one. Wait, what the hell? That's a cycle, right? Wait, this is literally a cycle, is it not? Wait, there's a. Oh, let me read this question properly. There's a cycle in the linked list. Uh, can you not? I mean, that is technically. Wait, what is going on here? There's a cycle in the linked list. I don't know. On the next, continuously following the next pointer. Internally, pos is used to denote the index of node. Note that pos is not passive. Okay, let's look at some constraints. Number of nodes in the list. The number of nodes in the list is from range. What, I thought like. Okay, so. Okay, so the length of this particular like, this is. Yeah, so like any length is basically between like 10 to the 5. I think no. 10 to the 4. So, okay, cool. Okay, well, the follow up kind of gives me a hint, I guess. Um, so I'm assuming the naive solution does not uses constant memory. So that's one thing I can kind of take away. That's a hint, right? Though there's no hint section, but I guess like the follow up kind of gives it away that I don't need to use a constant memory um, for this. Okay. Uh, okay, so I have an idea. Let's talk about this idea. Obviously, things we have seen, we need to kind of record things we have seen, right? Um, Hash map list. So let's make a list of all the numbers so that can possibly happen. Um, so you know 00 yada yada yada, right? So this list would like be 10 to the 4. So every possible number that can exist will have an index. So, for example, like in this particular case, right? Like 1 exists. So what we can do is like we can turn on activate this particular region. 2 okay, 2 exists. We can activate this region. Can we do that? Is it too big? Nah, actually, that's not true. I mean, the idea is true, but like we need a quite a big list. So in fact, we need 3, 4, 5. What's that? 100,000. So we need like 100,000, like um, and then we also need like 100,000 over here. Um, 1, 2, 3, 4, 5. Actually, no, we just need 10,000, right? Um, yeah, we actually just need 10,000. Sorry, my bad. Um, so yeah, this list would expand like say from here to here. And then basically this will have like a heat map, like is your binary mask. Okay, so and all we need to do is like basically check if it existed, if it has existed before or not. So imagine if this was okay. So in the case, right? Um, in this case, uh, 3 say 100, okay. And I'm assuming 3 again. So what we'd have is like obviously starts with 0, a lot of zeros, right? So this is 0 mark, and this is minus 110,000 mark, and this is like um 10,000. And obviously this would be like your 0. Okay, so imagine like this is like 100. This is 100, and so on. Okay, so what we can do is like, okay, we see a 3, we activate the 3. So 0, 0, 0, 1, 2, 3. So we activate this 3 position, and then we kind of go like to the next. We kind of go to the next number, which is 100. So we activate this particular position, which is say 100, and then we see a 3 again, and then we kind of go back to this index 3. Oh, look, it's 1. So it has been activated before. Therefore, it's a tail. Like, therefore, there's a cycle. I think that's pretty much it, really. Um, I mean, creating this particular list is a bit like it's not complicated, but handling it is a bit finicky. So maybe what we can do instead is like, what can we do? Can we just create a hash map? Like, let's just iterate through like 10 to the 5 to 10 to the okay, and create a hash map like and then set their values to 0. Hash map and set the values to 0. That's technically that's what we're doing, but just list form, and then just kind of like access whether it's activated or not, whether they were actually activated or not. So yeah, let's do that. I think, and then we can kind of think of like how we can kind of make this more efficient. But I think at a surface level, I think that's what it is. All right, what is the problem number? One for pi. Optional. All right, okay. Honestly, writing a test for this is kind of hard, but all right, let's initialize a map. I'm making this a class variable. Okay, map. And 0 for I in range like minus 10,000. Think to like 10,000 plus 1 because we want to cover that number. Okay, so that's that. And what we can do is for head. Okay, well, okay, let's do this recursively. Okay, so we just consider about the first head if we want to do recursively, and then we can kind of like use the same implementation to kind of solve the problem for the second head. So how would we solve the problem for the first head? Well, we would check if head.next. Okay, file. We would check like if self.map, right? If we have stored this into a variable, well, if this equals to 1, then we return false. Okay. Else what we do is like, okay, we mark it as seen. We mark this particular we mark head val as seen. Okay, cool. And then, okay, we're kind of like, okay, do the work for me, please. Okay. Actually, self.has cycle. Self.head. Actually, so we want to do the next for the next guy. So we want to do like, it's not self.head. It's just next. Okay, go check out for this guy. And well, I'm assuming this guy will return exactly one way I can kind of imagine is like it will just return this exactly it, like that's what we want to do is like has cycle. Has cycle is like say false the beginning, and we want to do has cycle equals to false. And has cycle equals to true. Okay. Actually, true and false. Okay, I mean, this is kind of, I think, okay, I have a feeling that, like, cycle. So, what I'm trying to say is, like, okay, well, for our particular node, we check if it has cycle or not, and then we kind of activate and deactivate, that particular cell. And over here, what we're saying is like, okay, well, because it's recursive, right? Like recursive thinking, like if we have a cycle, or basically if our child, like the next node tells us that it has a cycle, then obviously we have a cycle, right? And if we think we have a cycle, then basically we take the or of it. It's true if one of it is true, right? So I'm not really sure how to write tests for this. Like, I mean, I kind of know, but it's kind of a hassle, so I'm not gonna test it over here. I'm just gonna get leetcode tested. Okay, so it looks like it's not a biggie. I feel like we're just missing one edge case over here. Non-type object has no attribute val. No. Ha, you're funny, dude. Non-type. Huh. Okay. So it looks like what we did kind of check head is to be true. What if head next is false? Head dot. I think this is also a next case, right? If it is. is none, then what we want to do is like return. Well, we know for sure that it doesn't have. Okay, I think that's pretty much it, really. Please. Oh God. Non-type happens with no vowel. Oh, okay, cool. Okay, I get it. Okay, I get it. Cool. Oh no. Honestly, dude. Okay. Okay, what's going on here though? Okay, at least we passed like 9 test cases, right? So which is a good sign. At least we passed like 9 out of 23 test cases, which is a good sign. Which is a really good sign. Okay. Um. I mean, isn't that like just it doesn't have a cycle, right? Wait, it's yeah. That's what. Oh, that's what is expected. Yeah, it doesn't have a cycle, but we're saying it has a cycle. Okay. Yeah, that is an interesting point. What actually happens though? Can you do the spin trick? Like, what do you mean the spin trick? Like linked list spin? There's a trick on a linked list that you can spin. Not quite sure. Uh, yeah. Oh, with a pen. Okay. Yeah, sure. Let me finish this question first. I think I'm really close. I hear you, but I just want to like focus on this question. Like, I talk too much, but I say focus on my question. Um, it's cool. Oh no, interviewer, I got this wrong. Oh no, I can't get to Google. Uh, no. Oh, I'm joking. All right. Okay. So looks like there's only one number. Okay. So there's only head being passed. If it is only head being passed, if it is only head being passed, then well, huh, well, head is none. Return true. Head is next. Oh, come on. Come on. False. Yeah, dude. I think we're good. I think we're good. Please, please, Lord. All right. Oh God. Okay. Well, 12 out of 23 test case passed. Well, okay, cool. Mm. All right, let's think about this. One, two. We're returning true, but it should expect false. Why are we returning true? It's kind of stupid. Like, I thought we returned false. Okay, head is not none. Yada yada yada. So we come here has cycle is false. Ah, ah, get it. I think this might be okay. Uh, all right, dude. This is kind of okay. Has why is it returning me true when? So okay, let's just think about this. Oh, I see. Ah, right. Okay, I kind of forgot about the fact that like cycle also basically means like this, right? You can have a point where like you have 300, right? Um, and then like three, and then this could be pointing towards this itself, right? So I totally forgot about this edge case over here. Um, yeah, it's this I didn't cover, so that we need to cover. Um, but how do we have? Okay, but how do we get? How do we know what pointer? Yeah, but like, how do we know that it's pointing towards itself? Wait, does it have like a variable called? Like, I know this is the solution, but like how do we get the pause? Like, pause is used to indicate the cycle is yada yada yada. Internally, pause is used to denote the internally used to denote the index of node the till is connected to. Uh, yeah. I'm kind of busy. Okay, internally pause is denote. Okay, honestly, these I don't understand the question fully. No, the pos is not passed as a parameter. Then how the hell do we know what pos this pos is? Like, how do we get access to the pos? Like, how do we know what the pointer is pointing towards? For that, we might have to kind of look into the solution, I guess. Um, God, dude. Oh, so why you got everything gotta be easy, slow, and fast pointer? Can we like Python it? Okay, let's look at the C++ code. It would be oh. Holy shit, bro! These guys are using while loops and. I think if a pos is smaller than the length of the list. Wait, I think if a pos is smaller than the length of the list. Like, what do you mean by that? Like, could you please explain what you're trying to say? Okay, this is exactly what I'm trying to implement over here, right? Like, I'm just doing this recursively. Uh, wait, no, this is not. This is not what I'm trying to implement. Okay. Okay. Sure. think if you're trying to say a Chuck key, you're trying to say if pos is smaller than the length of the list. Um, Yo, this like read this solution is kind of weird, but no. Um, like, to be honest, I really don't understand the solution. It's like, um, why is everybody just trying to give us O of n solution? I'm looking for suboptimal. Holy shit, dude! Floyd Torsey and Harry algorithm. Honestly, dude, I literally don't understand what this pos is. Like, pos is something that we don't know, but exist. So we don't know what pos is. It's not. Right. I see. I see. So what's happening over here is like this is what's happening over here. I believe this is what's happening here. So imagine this is the node case, right? Points right here. No, I don't know. Honestly, I'm not sure. Oh, this, how's this an easy question? Oh, how is this an easy question, dog? Oh. Like, who is calling self dot has cycle? Like, okay, I'm gonna kind of look at the solution. I think it's time.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve linked list cycle. I know that we solved a problem that's pretty much a harder version of this exact problem, but in this explanation I'm going to explain why the tortoise and hare algorithm on a linked list cycle, why exactly it works and why exactly we know for sure that it's a linear time algorithm, because I think most people just kind of glance over why exactly this is true. So I'm going to go over that today. And you can see that this linked list problem is another problem from the blind 75 list, a list of 75 problems we've been working through and tracking on this spreadsheet. The link to the spreadsheet will be in the description if you want to take a look. We are not quite done with this sheet yet, even though we have done pretty much most of the difficult, medium, and hard problems on this list. So basically we're given the head of a linked list, and we just want to determine if there exists a...
Oh, sure. I mean, to be honest, like I can't do with this finger, but there you go. Bro, I'm not in the mood, bro. Like,
a cycle in this linked list or not. And basically the definition of a cycle is...
I can physically like I've been doing this since I was like, what, like 12 years old or 14. I learned it at school. My friend taught me, and then it's just been a subconscious thing that I've been doing ever since. I've been trying to kind of add the other stuff, like add the other, like, but never got to it.
if at some point,
All
you
right, dude.
click
Let's look at the
to a
solution here.
node and you keep following the pointers along that node, eventually you'll get back to the same node. And if we get
Yeah, I
back
guess
to the
so.
same node, we'll be able to do it again and again and again, basically an infinite loop. So we return true if there's a cycle, we return false if there's no cycle. Now the first idea you might have is just start at the beginning, keep going to the end, keep going, and eventually let's say that this -4 actually pointed to null, in that case, we know, okay, we got to the end of a linked list, right? So in that case, we return false, no cycle. And that's always going to be the case. So if there's no cycle, it's really easy to detect that there's no cycle because eventually we reach null. But if we don't reach null, right, we go along this node and we get back to the same node we already visited, but for some reason we can't detect that, so then we go to the next node, and keep doing that. And from our perspective, we're just going to say, okay, it's just a really long linked list. Eventually we're going to get to null, right? But that's not going to be the case. If there's a cycle, we never get to null. We'll never break out of this loop. So we really have to determine a way to detect that we're visiting the
Oh,
same.
I see. Okay. Sorry, man. I was just trying to help you. Dude, it's fine, man. It's fine. Just chill. It's all cool. Uh, I don't even know what you're sorry about. Like, I'm just kind of pissed that, like, okay, so it looks like, back to the problem, dude. Like, it looks like we are in the cycle. Like, we have not detected the cycle, therefore we've been constantly going in a loop. Um, so yeah, which makes sense because this is the case, right? This is a cycle over here. It's a cycle, and we cannot detect the cycle because dummy has put in this value. Wait, this is not a cycle? Wait, dude, this is not a cycle? Like 1 and -1 is not a cycle? Oh, okay. Plus is -1 or invalid. Ah, okay, cool. I see. Well, I guess like if uh do I ever take breaks? Yes, I do. In fact, I might have to go for dinner now. Um yeah, I'll actually go for dinner and then how long have we been streaming for? Do you know? Let me check. Well, okay, I think we will kind of like code for like try to solve this problem until like 8:30. Currently it's 8:23. Um yeah, I just kind of check over 1.5 hours. That's right. Yeah, that's right. Good point. We have not taken breaks. Because this is an interesting problem. Like, I don't know why I can't solve it. Like, so, well, okay, well, we're gonna take breaks in like 5 minutes, all right, and then It's fine, dude. I'm good.
Same node twice. So how can we determine if we're visiting the same node twice? Well, we start at the beginning like usual, and we maintain a hash map or a hash set. In this
I was thinking about, like, bro, that's my solution, bro.
case, where basically we take every single node and we take the node itself and add it to the hash set after we have visited this node. We don't add the value because I think in this problem there could be duplicates, right? Like the same value could show up multiple times in multiple nodes. So we don't want to detect a loop that way, but we'll take the node itself and then add it
Oh, right. So it's not the value we're checking for, it's the node we're checking for. Okay, that's one thing.
to the hash set. And I think you can do that in most languages. You definitely can in Python because the node itself is just an object and you usually can hash an object.
Okay, cool. Now that we have information, can we actually solve it? Uh, so. Okay, we might have to rewrite this a bit. Actually, dude. Uh. Actually, dude. Hold on. Yeah, has cycle equals to false. True. Uh, it is not Java. It's Python. Um, but who cares, bro? Who cares? It's the problem we're solving, not the language. Uh, the language is not too important for now. We're not too bothered by the language. I mean, I guess like this should work. Hey, call me. Welcome to the stream, dog. We are doing some leak code today. Oh my god, it worked! It worked! Holy crap, it worked! Holy crap, it worked. Well, that's interesting. Um, so my solution is as follows. I mean, kind of, it's not too different, like from like previously. So, just a quick rundown on what I did. Um, so what we did over here is like if we have like 100, right, and then we get like uh 10, okay. So what we did was like we maintained a map like a set, a particular set only has like unique objects, right? So like basically for each of them, what we do is like we kind of copy, we kind of check if it exists in set. So if it has been added, if this particular object has been already been in the set, um, then we know that it's a cycle, right? Because take an example, okay? In this particular case, we're okay. In this particular case, we add 3, all right, and then we add 100, right, and then we add 10, and then we're back here again. We try to add 3 again. When we add 3 again, well, we kind of realize that yeah, it's already been added, so it's a cycle. If it wasn't a cycle, then you would not have you would the element you were trying to add would not be present in the set. So that is the solution. Um, but it's not an optimal solution, so we will have to kind of work through this. But for now, I'll accept this. Yo, by the way, I will also make the repository like that I'm kind of adding on, like a public repository. Um, so you guys can definitely go on and kind of. Actually, I don't know. Should I? Because I do have my colleagues. Uh, to be honest, I don't even know. This is simple. Maybe this is an introduction. Sure. Welcome, Kaleem. Welcome to the stream, dog. Welcome to the stream. We'll be out here doing leak code every single day around this time ish. Uh, about like 6 I kind of start streaming. So tomorrow definitely like hop on. It's about to kind of time that I kind of leave. Yeah. With that said, I feel like we are done for today.
Okay, so we're good.
At least stream wise, we are kind of done. Um, Behind the scenes, I'll definitely like kind of looking for the optimal solutions. I'll kind of implement the optimal solutions, but I don't know actually. To be honest, I don't even know how to kind of implement the optimal solution for this and the problem we did earlier. So I'll have to kind of think through that. Um, yeah. So that's that. Uh, Chucky, I'm not sure if he's still here. But if you're here, thanks for coming to the stream. Kaleem, bro, thanks for coming to the stream. We'll be out here tomorrow as well, trying to solve some leak code problems. Um, yeah. Peace, guys. I'm leaving because I'm hungry and I have to go take a dinner. Um, I'll probably stream longer in the weekends though. So but not this weekend. This weekend I'm kind of busy. So, all right, take care, dude. See you tomorrow and hopefully tomorrow. If I don't have an event, I don't know. I need to check my calendar though. All right, bye, peace.